Hello everyone, welcome back to number 5 of the Java for Beginners course. In this one we're going to look at some more primitive types and understand what wrapper classes are. So as always, each episode we're delving more and more into Java and we're going to be doing some more cool stuff. So let's get straight into it. So in the last video we saw the 8 primitive data types. Let's remind ourselves what they are. So we have byte, we have short, we have int, we have long, we have float, double, boolean, and char. So if you remember, the differences between these is basically the size and how much information they can store. We've already met int, we've already met float, double, and boolean. The other ones we still are yet to cover, and we'll do that in this video. As mentioned, some of these are not as common, so you won't be using them as much, but it's still worth knowing. There are better ways to represent such data and to do more with them, and that's what wrapper classes are. We'll get into that straight after we remind ourselves of the primitive types and look at the other ones. So let's get straight into the code. So I've opened up IntelliJ and I've just got a brief kind of summary of what we've been learning. So these right here are the primitive types. So if you remember, we have an integer which we create by writing int as the type, which is the primitive type for integer. We've got boolean, which holds a true or false value. We've got a float, which stores decimal numbers from 6 to 7 decimal places, or up to. We've got doubles, which is a lot more precise if you remember, which goes up to 15 decimal places. And these are how to create these variables. We have to put a d at the end to show that it's a double, and a f at the end to show that it's a float. For long, so long is a new one, this stores 8 bytes worth of whole numbers. So if you remember from that diagram, a long could hold the most amount of data. Now, if you've noticed, IntelliJ is actually flagging this up. So what I've done is I've created a long just the same way we created our other variables of the primitive types, but notice that it's highlighted the value over here. If we hover over that, it says long literal 1L ends with a lowercase l. Now the reason why it's highlighting that is because this L, maybe if we had a really long number like this, that L doesn't look very convincing. It kind of looks a little bit like a 1 maybe in certain text editors, for example. It can be quite confusing. So what IntelliJ is actually suggesting is we use a capital L, just like that, and that looks a lot more clearer, and you can see the error has gone. This is absolutely valid, by the way, for like doubles and floats. We can actually replace them with the capital value. But I think for those, they're quite clear what they are. The next one we've got is a short, and a short can hold whole numbers from minus 32,768 to 32,767. So it's smaller than an int, but it is larger than a byte, and this is how you define a byte. A byte stores whole numbers from minus 128 to 127. Just to show you this in practice, if we did change this to, let's say, 135, notice here that the compiler is complaining, and because we provided a int. So Java uses ints as default, by the way, so we can actually just set that back to 127 maybe, because that's accepted. And finally we've got char, and char just stores a single character, and you have to provide it in single quotes just like that. So if we do more than one, you'll see that it doesn't like it. Too many characters in character literal. So this is just a refresher of the primitive types from the table, as well as how to actually define them in the code. So it's no surprise to you guys that we literally just write the name of the primitive type as the type. So there we go. And you might have noticed that I'm adding stuff above this. Now, these two slashes over here represent a comment. That's also why they are highlighted. Well, they're not highlighted, but they're in kind of like grey text. What this is, if you add 2 slashes in front of anything, it gets ignored. So this is called a code comment. Now, some companies prefer kind of cleaner code, so they don't actually like comments, but when you're starting out, comments are a great way to just maintain your code. So maybe, we've created, so if I added these lines here, this would not create my variable. So by adding these comment lines over here, we are completely ignoring this. So when the Java code is running, it will go to this line, it will skip this line, and it will go straight to this line. So just bear in mind that comment will make the compiler ignore it. So for example, if we tried to use this variable, so if we did a print statement underneath and we printed out the value of my boolean, but now we add the 2 slashes, notice here it says it cannot find my boolean because we've commented out. So comments can be useful, so definitely when you're starting out, if you want to just kind of jot down information like I have, but you don't want it to be picked up in the code, dash some backslashes there, or forward slashes I believe these are, so it can comment it out and it can get ignored. So a much better way of doing more with our data is by using wrapper classes. So you might be thinking, what is a wrapper class? Well, a wrapper class is simply just a class in Java. Remember, a class is just basically a file which stores a piece of code. It's an inbuilt class provided by Java that literally wraps around these primitive types so we can do more things. And it kind of converts a primitive type into a object, right? Now don't worry too much about objects. We will cover that in further videos as it's a much more advanced topic. But for example, we have a integer over here and we've got the value of 1 in it. Now we can use a wrapper class to wrap around this integer to unlock some extra properties and variables. So if you remember back in that table, we had a minimum value and a maximum value for an integer. Well, we can actually print that value out directly using the wrapper class. I want to show you exactly what I mean now. So to do the wrapper class version of an int, so basically just think of it this way, they're exactly the same thing. You can just do a lot more with the wrapper class. So the wrapper class version of an int is simply integer, just like that. And notice it starts with a capital I and is not highlighted in orange, as this is not a primitive type. It's in fact wrapping around this primitive type. And remember I told you that this gives us access to properties and behaviors, or more commonly called methods and functions. So remember, this itself, this little code block here, is the main method. So in the same way, this class has its own methods, not the main method, but it has its own blocks of code that does stuff. So let's recreate this line using the wrapper class version. So let's call this my integer, so we're clear, and let's also equal it to 1. Literally, it's as simple as that. We've created a wrapper class version of the primitive type int. Now let me show you exactly what I mean by properties and behaviors. So let's write a print statement for my int. So we are now accessing this variable, so it will print out 1, right? If I put a dot here basically lets me access this type. And if you've noticed, there's nothing really there that's useful for me. var just converts it into a variable. This is using something called lombok. Basically, I'm not even sure what some of these even do, because they're pretty useless, right? Now watch if I do the same thing down here. So let's do my integer and put a dot. Well, look at that, and notice here we've got a pink kind of circle with an M in it, and that stands for method. So with this integer value of 1, we can convert it to a byte, we can convert it to a double, we can do all sorts of stuff. We can convert it even to a string, and these are called methods, right? And remember how I said there are also properties? Well, remember how I said that integers have a max value and a min value? What if we wanted to see that in our code? Well, if I start typing m, look at that, max value and min value. So if I click max value there, and let's see, access static via class integer reference, let's just click that. Right. So what happened there is if you press the command button and click into this, so if you hover over the property or even this, just to let you know, if you hold command, it will allow you to click into certain things. So for example, if we wanted to see how integer works, if we hold command and click on integer, we have accessed the integer class, right? And we can see all the things that an integer can do. But don't worry too much, because it might confuse you at this point. But just for this sake, what this is saying is we need to be using integer itself. Notice here we're actually calling my integer, which is the name of the variable. What this is saying is it needs to just be using integer, because the property is for all integers, right? Not just my integer has a max value. All types of integer have a max value. So if I click into this method, or this property, sorry, we know that it's static. Basically, static means you didn't have to create the object. So we didn't have to create an integer and equal it to 1 to know, to know that the max value of an integer is so and so. Because the max value is attached to the integer itself, the actual type integer. So let's go ahead and run this piece of code. So we printed out 1 for this line up here, where we print out my int, and in the second line, would you look at that, it's printed out the maximum value an integer can hold. So if I copy this value and put that on here, and maybe change this to a 9, you can see that it's complaining because the integer number that we've supplied cannot fit in a integer. So this is essentially what a wrapper class is. It's the same exact thing, but it can do so much more. For example, we can use boolean again. So let's do, I'll tell you what, let's put these together. So if I delete that, stick it here, and for a boolean we can do the exact same thing. Remember, these ones start with a capital letter, so let's do boolean. Oh, there you go, IntelliJ has already suggested it for us. And let's do my boolean wrapper. We'll call it my boolean wrapper, and let's also make this equal to false. Okay, and here we can do a print and print out the value of this boolean, which should just print false. And let's do the same here and do my boolean wrapper, which will also print false. But again, if I press dot, which allows me to access the properties and stuff, I don't have anything to really work with. And let's do the same with my boolean wrapper. Oh, look at that, we've got loads of things to work with, right? We can compare it to another boolean which returns an integer, which is interesting. We can convert it to a string, so maybe we wanted false as a string, you know, like literally like this. That's a keyword in Java. As you can see, it's highlighted in orange, which is why we couldn't use false there as the name of our variable. But what if we wanted something like this, right? We wanted to convert it to a string. So we can do that directly here by doing this. So another way that toString method would come in handy is, instead of making this equal to false with these quotes, we can directly do my boolean wrapper dot toString. So that's converted this into this. Now let's see what IntelliJ is saying here. This is actually saying that we can just use the primitive type. So remember how I told you a bit earlier that primitive types are quicker to use? So IntelliJ itself is recommending us to use a primitive type where it makes sense, right? Because the Boolean class is doing a lot. You can see it's implementing these. Don't worry too much about that. But you've even got kind of like static properties up here that create a new Boolean with the false value. Again, don't worry too much about this. We will touch on these kind of concepts a bit later on. But IntelliJ is just being, you know, being real with you and saying just use the primitive type, just like that. We can notice that this changed this line though. Reason why is because we don't have access to toString. Now I hope I've explained what wrapper classes are to you guys. So as I told you before, all of these will have one. All of these primitive types will have a wrapper class version where you can do a lot more. So even float you can use with uppercase. You've got double like that. We've got long. We can do capital L, and we have short. Can use that. Byte. We have char as well, which is character. So these are the wrapper classes for these specific primitive types. Okay, so simply just put a capital letter and IntelliJ will do the hard work and give you that. But now, what if you wanted to kind of convert between types? Or let's think of a problem scenario. So in Java, if you write a whole number, by default an integer is used. So let me show you exactly what I mean by that. So now we've understood kind of what wrapper classes are. Let's look at a concept called casting. So casting is something that is there in other programming languages. It's not exclusive to Java, but you might have certain scenarios where you need to convert from one type to another. Now let's look at one of these problem scenarios. Let's say we create a variable of type double, called it myDouble, and did 5 divided by 2, just like that. Notice here, IntelliJ is actually saying that you've used two integers in a floating point context. Now, the issue here is Java will automatically consider whole numbers that you've entered as integers by default. So this 5 over here is an integer, and this 2 over here is also an integer. But we need doubles, right? So yes, the quick fix right now would be to put a D, just like that. And that's literally splitting 5 as a double divided by 2, right? So that would work. But another option of converting something from one type to another is casting. And to cast something, we'd simply provide some brackets, just like that, just before we do whatever we were doing. And inside the brackets, we state what type we want. So in this context, we want a double, right? So where this here is going to provide us an integer by default. So if we type in double here, the error's gone, and it absolutely works fine. So if we did can't type, if we print out the value of my double now, and let's give this a run, we'll see that it prints out 2.5, right? And if we got rid of that and run that, notice it got us 2.0, because by default it's dividing to integers rather than to doubles. Okay, so that's simply what casting is. It's from converting one type to another where it's applicable. So that's kind of a quick introduction to primitive types, wrapper classes, and now casting. Okay, so just to recap, primitive types are the most basic types in Java, and they're the building blocks for data manipulation. Wrapper classes take that a step further and give you some properties and functions or methods to work with. So just to show you again, if we wanted to print out if we wanted to convert myDouble into a string, we can do this. MyString equals let's create a new variable above this of the wrapper class for double. So let's do double myDouble wrapper, just so it makes sense, equals 50. Let's just do 50D like that, right? We can do myDouble wrapper dot toString, and now essentially we've converted this into a string. So it now technically looks like this. And we can do that, printing out my string. If we run this, we won't be able to see the quotes, but it has converted it into a type string. So it absolutely works this way, and we've got great access to different methods and properties simply by adding a dot at the end, okay? And this only will work for the wrapper classes. And the last thing we learned was casting, which, as you can see up here, we write some brackets. So this only works in certain situations where you need to convert from one type to another, and you're using kind of like the example here, we were using integers by default because that's Java's preferred go-to for whole numbers, but we wanted it in a double context, so we need to add a double casting over here. So hope you enjoyed this video, and please don't forget to hit the like button and subscribe for more content that's coming up very shortly. Thank you so much for watching, and I hope you're enjoying these tutorial videos.